Hi and welcome to topic 3 of Unit 1 for General Mathematics, and here's some harder equations questions that we're going to look at today. Okay, so let's have a look at some linear equations that involve fractions. We still have our a on both sides, we still have our brackets work, but we're going to just deal with the fractional ideas as well. So let's start with this linear equation. Now, we've got a couple of options here because we do have our fraction, but it's still a fairly simple equation. It's actually just an equation where instead of 2x, we've got half x. So instead of dividing by 2, we're dividing by half. That's one option. We could deal with it like that. Or we could deal with the fraction as it is, and then we've got a plus 1 equals 7. We could multiply everything by 2 and solve a simpler equation from there. But what I'm going to do is I'm going to show you that we can unwrap this x in a clever way here. So I'm going to subtract 1 from both sides first. And that will leave me with x over 2 is equal to 6. And then to solve this equation, I'm going to multiply by 2 because the opposite to division is multiplication. And x over 2 means x divided by 2. That leaves us with x equals 12. Now this is one of those rare occasions where I'm not going to champion the idea of getting rid of the fractions first. And to get rid of the fraction first here would have been to multiply everything by 2, which I'm not going to suggest. Over here, on the other hand, I am going to suggest that. I don't like fractions, don't mind brackets, but I don't like them too much. So let's remove this fraction first by multiplying everything by 5. We have to remember here that we have a single term, a term here and another term there, and everything needs to be multiplied by 5. So I'm going to be really clear about this by showing you how you could use brackets to ensure that it works. Over here, when we multiply by 5, we're left with 2a minus 3. Over here, we've now got 5 times 3a plus 1. So that's just being clear and careful that we multiply every element of this by 5. So here we end up with 2a minus 6, that's this expansion, and here we end up with 15a plus 5. Then I'm going to add 6 to both sides. 2a is equal to 15a plus 11. I'll just write that down, plus 6. And then I'm going to subtract 15a. And I'm left with negative 13a is equal to 11. And this is not going to be nice, but I'm going to divide by negative 13. And that leaves us with a is equal to negative 11 over 13. And there's our final solution. So it's not as nice a number, but you know what? Fractions are easy to deal with. It's about 0.85 or something. I don't know what it is, but it's not quite 1. It's negative, so it's negative 0.85. But that doesn't really matter. I can build this down as long as I'm clear and I do everything right, and I'm going to have the right answer. This one was a bit simpler, and that's how we deal with fractions and equations. And here are some other examples of anything else, and not strictly linear. So now we're going to do 2 more equations, the last 2 of the video. We'll start over this side, linear equations, and we have 1, 2, 3 terms, 1, 2, 3 fractions, and a bracket, and x on both sides. So that's a bit of everything all rolled up in one. Now, the first thing we want to do is remove those fractions. That's really what we want to do in most cases. So I'm going to start by removing the fractions. And one way you could do this is to multiply everything by 2 to fix that one, everything by 3 to fix that one, and then everything by 6 to fix this one. That is an answer that will work every time, but you do get some pretty large numbers out of it. So we're going to try and be a little bit clever about this. What I'm going to recognise is that 6 is our lowest common multiple of our denominators. 6, 3 and 2 all divide 6 evenly. So if we multiply 3 by the lowest common multiple, we get this. Now I'm going to take it slow. You could do some cancelling at the start, but I'm going to take it slow. So we get 6x over 2 minus, so 6 times x over 2 is 6x over 2, minus 42, because that is 7 times 6 over 3, is equal to, now I'm going to take this on a little bit farther, because 6 is the same as that, I know it cancels out to give 4x minus 1. Now over here, 6x divided by 2 is just 3x, and 42 divided by 3 is 14. And that's equal to, I'm going to expand this, 4x minus 4. Now I'm going to add 14 to both sides. This is now a pretty easy equation with just x on both sides. Add 14 to both sides, and I get 3x is equal to 4x plus 10. And then I'm going to subtract 4x, and I get negative x, because 3x minus 4x is negative x, equals 10. And then I'm going to multiply by negative 1. And I get x is equal to negative 10. Now if I had to verify this equation, I could simply go through now, put negative 10 into the equation, negative 10 over 2, which is negative 5, minus 7/3 is, and you've got a calculator, it's negative 7 1/3, or negative 22 over 3 as a top-heavy fraction. Over here, 4 times negative 10 minus 1 is negative 11. Negative 11 times 4 is negative 44 over 6, is the same as negative 22 over 3. So we get equivalency on both sides, and I've verified my answer is correct. So I'm very happy with that. Now let's have a look at our second one. And our second one, 2x squared minus 8 plus equals 42 is actually a quadratic equation. So it's not linear, but you could be taken to this extent maybe. So we're going to talk about this very briefly and how you don't have to be worried about these. If you get a quadratic equation, so it's got an x squared term, but there's no x term, there's just a single x situation here, you can solve it using the techniques we've done before. You don't need any of that fancy quadratic stuff from mathematical methods. So here I'm going to start by adding 8 to both sides. I'm just unwrapping this x squared. And it gives me 2x squared is equal to 50. Then I'm going to divide by 2 to remove that 2 factor, which gives me x squared is equal to 25. And then I'm going to take the square root. So this is the unwrapping of x squared, and it gives me x is equal to the square root of 25, which is equal to 5. Now you've seen this before. You've done this in Pythagoras' theorem, at least, if not in other places, and so you've seen this idea before. If you want to be really clever about it, when you take a square root, we actually do get 2 answers. We get the positive and negative version. So negative 5 times negative 5 is also positive 25. That would be taking it that step further. But for now, this covers us for the value of x from this equation. Well, thanks for joining me on what has been an exciting adventure.